お時間になりましたので、ただいまより九州大学エネルギーウィーク2024エネルギー研究教育機構プレナリーセッションを開催いたします。本日司会進行を務めますエネルギー研究教育機構の山崎と申します。どうぞよろしくお願いいたします。はじめにエネルギーウィークの主催者である九州大学総長石橋達郎より皆様にご挨拶申し上げます。石橋総長、どうぞよろしくお願いします。
皆様おはようございます。九大の石橋でございます。主催者を代表いたしまして一言ご挨拶を申し上げます。本日は九州大学エネルギーウィーク2024の開会に際しましてウェブを含め、多くの皆様のご参加をいただきありがとうございます。また講演者の皆様には、伊都キャンパスまでお越しいただき、改めて御礼を申し上げます。九州大学はエネルギー分野の優れた研究実績を生かして、グローバルに深刻化するエネルギー、環境問題の解決と、持続可能な社会の実現に寄与するため、2016年10月にエネルギー研究教育機構を立ち上げました。本機構では200名を超えるエネルギー関連分野の研究者を結集いたしまして、学際融合研究を推進しております。また、昨年4月には、九州脱炭素化研究会を発足させ、現在22社のエネルギー関係の皆様と本機構の研究教育の成果をもとに脱炭素関連の産学連携を推進する取り組みを進めておりるところでございます。九州大学は本機構が中心となり、我が国が目指す2050年の脱炭素社会の達成に寄与するため、地域社会と共同してカーボンニュートラルの実現に向けた取り組みを展開をしております。今年度のエネルギーウィークでは、GX に向けた未来エネルギー技術予測と AI 活用をテーマに、AI、メタバースおよび未来エネルギー技術予測などを活用したグリーントランスフォーメーションに関する動向に焦点を当て、各界より著名な研究者の皆様をお招きし、さまざまなイベントを開催いたします。今日と明日は本機構によるプレナリーセッションと3つのフォーカストセッションを開催をいたします。この他にも、カーボンニュートラルエネルギー国際研究所 I2CNER や水素材料先端科学研究センターなど、本学のエネルギー関連組織によるシンポジウム、再生可能エネルギー連携フォーラム、それから九州大学 ISIT 福岡市連携グリーントランスフォーメーションシンポジウムなどを開催する予定でございます。ぜひこれらのイベントにご参加をしていただき、九州大学のエネルギーに関するさまざまな研究に触れる機会にしていただければと思います。この5日間のエネルギーウィークが皆様にとって有意義なものとなり、これからのご活躍につながることを記念して開会の挨拶とさせていただきます。どうぞ5日間よろしくお願いいたします。
石橋総長、ありがとうございました。それでは早速特別講演に移らさせていただきます。はじめに広島大学 IDEC 国際連携機構アユーブ・シャリフ教授より Integrated Approaches to Climate Change Adaptation and Mitigation in Cities と題して発表をご講演をいただきます。
皆さんおはようございます。Good morning. Thank you very much for the invitation. I particularly want to thank Dr. Roman Silichanian for his kind invitation. So I am Sharifi from Hiroshima University, and today my talk will be mainly focused on climate change adaptation and mitigation in cities. It's kind of a broad perspective towards energy transition in cities. I hope you'll find the contents useful for this week. I will first start with a broad landscape and research on climate change in cities, then reporting some highlights from the most recent IPCC report. Following that, I would like to focus on the concept of co-benefits and trade-offs between adaptation and mitigation in cities, and how using that integrated approach can help us achieve transition targets. So let me just start by why cities are important in the context of climate change. We know that climate change is often studied at the global level, but the impacts are mainly felt at the local level, and cities are major contributors to global climate change, as I will show some data later. They have also been centers of innovation throughout the history, so it is hoped that through innovation in cities, we can achieve some transition towards addressing climate change. And also, cities in many parts of the world have shown the commitment, actually, to address these issues. We now have different coalitions, for instance, C40 cities. These are several big cities. And later also show some data showing that because the majority of population lives in cities, actions taken by cities can make a big difference. In 2015, we had the Paris Agreement, where two major targets were set. One is the 1.5 target, and the other 2-degree target. And both of them are ambitious, although the 1.5 degree is often called ambitious. So they're ambitious because currently the amount of emissions that we have is about 42 gigatons per year. And as you can see from this carbon clock from MCC Berlin, the clock is really ticking. So this means that at the current rate, the 1.5 degree target will no longer be achievable in about 5 years, because the remaining budget is only 230 gigatons. And for the 2-degree target, the situation is more achievable, because we have about 1,000 gigatons of budget left. But at the current rate, that could also be consumed in about 23 years. So this means that we really need to take action quickly. And IPCC also has this RCPs, which are carbon concentration trajectories used in IPCC models. And as you may see, for the future, we may have different levels of global warming depending on actions that we take. And all these scenarios actually are possible, and they depend on actions that we take today. And here you see that progression of land surface temperature, for instance, for different RCPs. And this color-coded map clearly shows that in the future, no matter what RCP we experience, most of the world would be warmer than average. And for RCP, some RCPs, for instance, for RCP 8.5, in the future, as you may see here, some parts of the world may not be livable, again, indicating the importance of taking actions. So now, shifting to cities, importance of cities has been more recognized recently because of the rapid rates of urbanization that we have experienced over the past decades. Some people refer to this as, for instance, urbanization bomb or urbanization revolution. So as you see, in 1950s, world was not mainly urban. Majority of world people were living in rural areas, and urban areas were mainly concentrated in the global north, mainly developed countries. And things started to change in 1990s, for instance. As you may see here, we now have more urban areas concentrated in the global south, and this is the areas where the majority of future population growth is expected to occur. And as you see here, in 2030, things will change drastically. So this is when the majority of world population will live in urban areas, and mainly in urban areas of the global south. In fact, UN projections show that almost all future world population growth will occur in urban areas of the global south. So on the graph in the top, you see that, for instance, by 2030, more than 3 billion of world population will live in the urban areas of Africa and Asia. And the thing is that most of these cities have not yet even been built. So there is a lot of opportunity to make changes to facilitate transition to low carbon development through building those cities in a more environmental friendly way. Because if they follow the same footsteps that people have taken in OECD countries, building cities that are not low carbon, achieving the targets, even 2-degree target will not be possible. Again, cities are important because they are the main contributors to global climate change through different sectors, including commercial buildings, electricity power plants, residential buildings, industry, transportation, and so on and so forth. And of course, the importance of building and transportation sectors cannot be overstated. But they also provide a lot of opportunities, again, because of the innovation capacities. So if we have innovation in different sectors, such as transportation and residential sector, it's possible to achieve some of those targets. And in this recent IPCC report, as you may know, IPCC started to publish chapters on cities since the fifth assessment report. So since the fifth assessment report, we have specific chapters for mitigation in cities and also adaptation in cities. These are results from the sixth cycle of the assessment report, where the data shows that with no urban mitigation efforts, emissions could more than double from the 2020 levels in a few years. But we can also take actions. For instance, if they are aggressive but not immediate, it's possible to meet the 2-degree target. And also, if we have aggressive and also immediate actions, it's also even possible to achieve the 1.5-degree target. And for the first time, IPCC will also have a special report on cities. So each cycle, there are 1-2 special reports, and this time the only special report will be focused on cities, again showing the importance of cities in addressing climate change. Again, there are different impacts that we can discuss. One of them, for instance, is the urban heat island effect, which affects millions of people around the world, causing cardiovascular diseases and different types of diseases during hot seasons. And also we have, for instance, coastal flooding. Again, this is from the most recent IPCC report. Here you see that for different parts of the world and different timelines, millions of people would be susceptible to coastal flooding. And these are just some examples. We also have other types of impacts that people are supposed to be exposed to, and things may get even more complicated when we have cascading effects of multiple effects combined together. For instance, having flooding combined with pandemics, or having urban heat island combined with pandemic others, and so others. And these are not the only problems that cities are facing. we have one sustainable development goal allocated specifically to cities because there are different other problems, such as, for instance, people living in informal settlements or slums. It's like 1.1 billion people. And other problems such as, for instance, lack of access to green spaces, issues associated with justice, being exposed to air pollution. That's something that a recent report showed that it's not only an issue that people face in metropolitan areas. Even small towns now suffer from that problem. And because of all these issues, it's important to also consider the importance of co-benefits, for instance, because only addressing climate change may not convince people to take actions. But if we show them that through taking climate action, it's also possible to gain other benefits, it's more likely to get them engaged. And that's why we also have special reports on cities, something like what IPCC does, but more scaled down. This is periodical reports that are published every 5 years. In terms of shares of emissions, the global shares of emissions that can be attributed to urban areas is increasing, and it's been increased from 25 gigatons in 2015 to about 29 gigatons in 2020. So this is a major increase, and it's now like about 70% of global share of CO2 emissions. And again, it's possible to make achievements. For instance, this is a study from the Coalition for Urban Transition. They looked into 700 cities with at least 750,000 population. And their estimates show that in 2050, the amount of emissions that these cities are responsible for is about 14 gigatons. And if we continue with business as usual, this may increase to over 17 gigatons by 2050. And as you may see, this would be a big change. But it's also possible to reduce it to 1.8. And as you may see, this will be a very drastic change. It may look too ambitious, but it's possible with mitigation wedges across different sectors. For instance, for building sector, this could be 58% mitigation wedge, and others also transportation sector, the materials and waste, they could also contribute to improving efficiency and achieving this climate mitigation targets. So given the importance of buildings, as we saw, the mitigation wedge is well over 50%. Here I just want to highlight some of the actions that we can take to achieve mitigation targets in cities. For instance, in terms of direct emissions, these are emissions that can be linked to, for instance, use of gas or use of fossil fuels in buildings and cities. It's possible to achieve targets through, for instance, optimizing the design of buildings, increasing the efficiency of building envelopes, to reduce demand for space heating and cooling, which is one of the main contributors to climate change, increase the efficiency of appliances, electrifying the cooking appliances, supporting building occupants to reduce energy consumption, and also rooftop photovoltaics and solar thermal installations. In terms of indirect emissions, which are mainly associated with the electricity demand and electricity supply that has been offered to buildings and cities, it's very important to decarbonize electricity supply, have demand-side management, optimize the design of buildings to provide thermal comfort and also natural light. This could be achieved through different ways of passive building design and also passive urban design. Increase the energy efficiency of building envelopes, again, to reduce demand for space heating. Increase the efficiency of appliances and lighting, and also support building occupants to reduce energy consumption. So estimates show that adopting energy efficient practices in buildings could decrease global building energy demand by 2050 by 33 to 44% compared to a business as usual scenario. And these reductions can be achieved by reducing, for instance, floor area, utilizing more efficient appliances and lighting, optimizing thermostat settings, and so on and so forth. But we also have embodied emissions that need to be considered. These are emissions, for instance, embodied in the material that is used for construction or any other transportation-related emissions, for instance. We can reduce those emissions through refurbishing existing buildings to make sure that less material is used, through specifying timber products from certified sustainably managed forests to facilitate transition to circular economy, supply chain, and also other measures such as integrated building design with life cycle analysis or providing space for urban food production and composting. One good example to reduce the emissions associated with materials is this switching to net zero emission materials because there is significant demand for buildings and infrastructure. Substitution for timber systems for steel and concrete would make a big difference, and it can help to transform cityscapes from their current status as net sources of GHG emissions into large-scale human-made carbon sinks. And estimates show that the construction of timber buildings for 2.3 billion new urban dwellers from 2020 to 2050 could store between 0.01 and 0.68 gigatons of CO2 per year, depending on the scenario and also average floor area per capita. And again, there is a lot of opportunity to achieve this because if you remember from one of my earlier slides, there will be a lot of population moving in cities, particularly in Asia and Africa. And this shows that there is a lot of opportunity. It just needs some commitment and investment from perhaps partner countries. So when it comes to mitigation strategies, it's of course not possible to have one size-fits-all approaches. So we need to acknowledge that cities are different. In this IPCC report, we emphasized on three types of urban scenarios, although it's important to mention that these are not mutually exclusive. So we may see combinations of different patterns like this in different cities. One is emerging. These are cities that are expected to experience major increases in infrastructure investment and infrastructure built up in the coming years, again, mainly in Africa and Asia. We also have rapidly growing cities, which are expected to experience major increases in upward through density and also outwards through, for instance, urban sprawl. And these cities will also have significant increases in infrastructure investment. We also have established cities. Those established cities are cities, for instance, like Tokyo, which already have established built-up structure, and their mitigation scenario strategies should also be different. So depending on these cities, the report highlights some specific mitigation scenarios and actions. For instance, for emerging cities, it is very important to emphasize electrifying building services using recycled material and net zero emission materials, having decision-making based on life cycle analysis, and also paying attention to urban design and layout. For rapidly growing cities, adopting compact urban development patterns is very important because it helps to minimize the outward growth through urban sprawl. And also, we need to pay attention to electrifying building services using recycled material and net zero emission materials to reduce embodied emissions, and paying attention to urban design and layout. For established cities, again, the most important thing is perhaps paying attention to refurbishment through, for instance, replacing, repurposing, or retrofitting the building stock, electrifying the grid, infilling and densifying urban areas, and also integration of smart solutions. Again, cities alone cannot address this issue, so it is important to have partnerships and coalitions. And this importance has also been acknowledged, for instance, in SDGs, where SDG 17 is allocated to partnerships. And for cities, they have already taken actions through partnerships via, for instance, regional associations or coalitions. Again, I want to, for instance, highlight the example of C40 city or 100 resilient cities. These cities have acknowledged this importance, are now taking action to move toward more integrated approaches in urban areas. So with that background, I would now like move to some specific examples related to climate change mitigation and adaptation in cities, and also want to highlight why taking integrated approaches is important. So climate action planning, it's a specific type of planning that cities undertake in order to achieve climate change adaptation and mitigation targets. And this often involves setting specific GHG emission reduction targets and actions aimed at reducing the impacts of climate change over short, medium, and also long time frames. So for over 100 years, cities have had urban planning sections. And those planning sections used to just follow conventional methods. But mainly over the past 10 years, because of the importance of climate change, those plans have in many countries been aligned with climate targets, giving rise to climate action planning. And of course, two components are the center stones of climate action planning. One is adaptation, which is focused on limiting vulnerabilities and increasing coping capacity, and is defined by the IPCC as the process of adjustment to actual or expected climate change and its effects in human and or natural systems. We also have mitigation, which addresses issues related to the drivers of climate change and is defined by IPCC as a human intervention to reduce the sources or sinks of greenhouse gases. And different cities have different types of climate actions. Depending on the city and its importance in the global economy, the targets are different. So we can see that most of global cities, like for instance Tokyo or London, they try to lead the way and set examples by adopting more ambitious targets. Like for instance, for London, it's 1.5 degree. The same for Tokyo. The city is trying to be more ambitious by hoping to become net zero. Some cities look into the issue from a more integrated approach toward adaptation and mitigation. But cities like Tokyo, for instance, have separate plans for mitigation and adaptation. So this can cause problems. And also, some cities do not refer to it as climate action plan. For instance, they mainly emphasize on renewable city action plans. But we did a study recently, and it's obvious that thousands of cities now over the world have climate action plans. And this gives us some hopes that we can perhaps achieve some of these targets. So when it comes to taking actions, there are hundreds of actions that cities can take. But the issue is that in most cases, they don't have enough resources to take all those actions simultaneously. So it is important to find ways to emphasize or focus on certain measures. Of course, this could be different depending on the context. That could provide co-benefits and avoid trade-offs. And those are something that I will explain later. So here, for instance, you see that some measures like, for instance, urban forestry, new energy systems, water conservation, these are measures that could help cities to simultaneously achieve both mitigation and adaptation targets. But despite that, traditionally adaptation and mitigation have been addressed separately in both research and practice. And this dichotomous approach is even evident in the assessment reports prepared by the IPCC. It may look ironical, but still the IPCC follows the same approach where adaptation is being addressed by Working Group 2, while mitigation is addressed by Working Group 3. So, of course, there are different reasons for this, although some of those reasons may not be valid anymore. For instance, in terms of spatial focus, adaptation is believed to be more relevant to the local and regional scales. These are scales where the impacts of climate change are more felt, while mitigation is more linked to actions taken at the global scale and targets set to reduce emissions at the global scale. Although more increasingly, this difference is not visible because we even have now targets for cities. And also in terms of temporal focus, for mitigation, it's supposed to be long-term. So in the literature, you may see towards the end of the century quite a lot. So it is believed that we still have time to address the issue through, for instance, technological changes, through negative emissions, so on and so forth. But for adaptation, because the impacts are occurring now and we need to take action, it's more supposed to be something that is linked to the short and medium term. But again, these things are changing. So there are also other differences where in terms of, for instance, nature of action, scale of cooperation, levels of uncertainty, and also justice issues, which due to time limits, I don't go into details, but I will share my slides, so later if you're interested, you can check them. So to avoid these problems and accelerate actions towards achieving climate change, I want to emphasize that we need this co-benefit approach, which takes into account 4 major interactions between adaptation and mitigation. One of those interactions is co-benefits. This occurs when implementing an adaptation measure results in ancillary mitigation benefits. I will give examples across different sectors later. We could also have synergy, which is more related to systemic approach, and this refers to a situation when simultaneous implementation of 2 or more measures produces benefits that are greater than the sum of individual measures. And of course, this is something that needs to be emphasized. So those 2 were the positive interactions, but there could also be negative interactions. The common one is trade-off, which occurs when implementing an adaptation measure has negative effects on mitigation. In other words, some solutions developed to enable cities perform better under future climate change may have ramifications for the efforts aimed at reducing GHG emissions. And finally, we could also have conflicts. This refers to situations where it's not possible to simultaneously implement 2 measures. So again, I want to emphasize that there are hundreds of measures that cities can take. So here I just highlight some of them, and I try to present them sector-wise. Hopefully it makes more sense. So when it comes to urban planning, perhaps one of the most commonly used measure is through density, especially when it comes to big cities. They always focus on measures such as, for instance, floor area ratio or the amount of density that is allocated to different parts of the city. And there is a lot of research showing that density can provide multiple benefits, particularly for mitigation. Because when we have cities that are denser, they are likely to be more energy efficient because those cities can facilitate better access to different resources. Or for instance, if you have wall sharing, for instance, something very simple, it's possible to also reduce the energy demand. Of course, this needs to be based on optimal design because as we will discuss later, densification itself could also increase emissions in some cases. But densification also can provide benefits for adaptation. So it's not only mitigation. Because for instance, recently you may have heard in the news that in some parts of Australia, for instance, or North America, and recently even countries in Europe like Greece, areas which are less dense and have more urban sprawl, more use of land, they are more vulnerable to flooding because they may affect the, for instance, water cycle in that region. Or they could be more vulnerable to heat-induced, for instance, wildfires. So through densification, it's possible to achieve multiple benefits for adaptation and mitigation. And it's not only densification. When it comes to urban design and land use planning, there are multiple other measures like land use mix, improved connectivity, improved accessibility, so on and so forth, that could provide benefits for mitigation and adaptation. When it comes to transportation sector as well, it is possible to provide multiple benefits. Transportation sector also, as you can imagine, mainly provides benefits for mitigation, but through saving energy and through also promoting active transportation, walkable cities, it could also help achieve some adaptation targets. For instance, it can contribute to more energy resilient cities that are capable of dealing with energy shocks. Or when people tend to walk more, they are, of course, expected to be more capable of adapting to climate change impacts. We also have other sectors like, for instance, waste or energy. So I will give some examples of energy later. But here, I just want to emphasize the importance of distribution and decentralization of energy systems, and also diversifying the energy profile based on renewable energies. Again, clearly, renewable energy technologies can provide benefits for mitigation. At the same time, they also offer multiple benefits for improving energy resilience. Because, for instance, centralized systems are mainly located in specific areas, like if it's, for instance, a nuclear power plant. It's mainly located close to, for instance, coastal areas. And if it is affected by tsunamis, for instance, the whole city would be at risk. But if you diversify the profile and have distributed generation systems, it's possible to avoid those kind of problems. One specific sector that can provide multiple benefits is green infrastructure. This could range from different measures, including, for instance, green roofs, urban greenery, urban parking, nature production, urban agriculture, so on and so forth, which provide multiple benefits for adaptation. At the same time, through, for instance, making the ambient environment cooler, or through, for instance, reducing water stress, they could also provide multiple other benefits, including those related to water energy nexus. There are also others, such as, for instance, those associated with urban governance and planning, like what we can do with building codes. Building codes can provide a lot of opportunities if they are updated, for instance, to promote insulation in buildings or to make sure that our buildings are designed based on more updated or more recent technologies. They can provide multiple benefits. And we shouldn't also underestimate the importance of behavioral changes. For instance, dietary changes are important, improving citizen awareness is important, and also providing incentives for managing heating and cooling energy demand. So with all those measures, I think cities can look into their own context-specific conditions and emphasize particular measures, particular sectors that would provide multiple co-benefits. So for instance, if a city has a very limited budget and cannot roll out measures across different sectors, they can emphasize on some specific sectors such as green infrastructure, which can help them achieve mitigation targets and also at the same time provide adaptation benefits. And more importantly, it's also essential to emphasize synergies. Again, this is when the sum of two measures is larger than the sum of their individual impacts. So again, if I give an example of density, for instance, density alone may provide some benefits for mitigation, for instance, through reducing travel demand. But it could provide even more benefits if you combine it with other measures such as land use mix of different uses in cities, or improving accessibility. Because if you have a lot of density in some parts of the city, but people still need to travel long distances to reach their work places, then you won't get the desired impact. So it is important to pay attention to those issues. So one example is in the energy sector, for instance. It is more ideal to combine, for instance, distribution and decentralization of energy systems with enhanced energy storage systems to deal with the fluctuations in energy supply, and also to combine it with electrification of energy systems and diversification of energy profiles. So if we have a combination of these different measures where each of them can provide mitigation benefits, we can have synergistic benefits that would be more transformative. Or when it comes to urban planning, one important concept is, for instance, transit-oriented development. This is when you combine density with other measures such as improving walkability or providing cycling infrastructure, providing accessible transport, improving the connectivity in the city so that people can walk more. And with all those changes, it's possible to achieve synergistic benefits and also mixed land use. So the good news is that in most cases, we can achieve co-benefits, but there could also be trade-offs, which are not very common. That's good news. But they should be also dealt with, and we need to make sure to have optimal design to avoid those kind of trade-offs. So again, if I give the example of density, if we have non-optimal levels of density, they may increase heat island effect, and this will expose people to urban heat during hot seasons and may cause adaptation problems. So we need to have those kind of optimal design, optimal levels of density to avoid such problems. And there are also some other potential trade-offs that could occur for other sectors. So it's not only density, but again, these are not very common. So these are some examples from the energy sectors. For instance, the centralization of energy supply often results in infrastructure redundancy. That is critical for improving resilience and also adaptive capacity of the system. However, this may result in mitigation trade-offs as redundant infrastructure may lead to less efficiency. Or deployment of distributed and renewable energy systems requires relatively significant amounts of capital investment, and mitigation benefits are likely to be achieved at high cost that may limit our capacity to have adaptation. There could also be conflicts, and these are really not common. For instance, if we have a lot of density, again, it may not be possible to implement, for instance, urban greening measures or neighborhood scale renewable energy technologies. But this could be easily avoided using optimal design. And I also, again, want to emphasize that it's not only adaptation and mitigation, and we shouldn't just approach this from adaptation and mitigation lens, because when we take mitigation measures, it's also possible to gain multiple benefits for instance, health, for economy, and as you may see here, for basically different types of SDGs. So if we approach the problem from that perspective, it's more likely to get people engaged. For instance, when it comes to taking actions at the building level, it's important to understand that we spend about 90% of time inside the buildings. And if we take actions to make buildings more energy efficient, it's possible to gain multiple health benefits, for instance, because we will reduce this, for instance, health syndromes in the building, and also create jobs, reduce indoor air pollution, so on and so forth. So it's possible to gain a lot of multiple co-benefits. So that was basically a summary of what I wanted to present. If you're interested, I would like to invite you to check some of our recent publications. For instance, here in this book, I've given more examples and more details on how we can achieve mitigation and adaptation targets in cities, including also use of new technologies such as machine learning and also AI. And in this specific papers, we have looked into more examples of interactions, co-benefits and trade-offs between adaptation and mitigation. And more recent studies, we have looked into climate action plans adopted by cities worldwide. This covers plans from different continents and how they can they can help the transition towards more sustainable cities and societies. So with that, I would like to once again thank you for the opportunity, and I look forward to interacting with you following the talk. Thank you.
Thank you. We have some time to do some question and answer. Do you have any questions? Let me start. So you showed a lot of opportunities and the combination of the to have a co-benefit to reduce the carbon dioxide from the cities. Do you have any recommendations to the Fukuoka city or the mayor of the Fukuoka how to have a co-benefit and to impact?
Yeah, thank you. It's a very challenging question. I think I've not been here many times. Maybe this is the third time. But I'm quite impressed by the way the city is close to the sea. So I think perhaps more focus on blue infrastructure, because there are also a lot of waterways and rivers across the city, and trying to perhaps creating some corridors, green and blue integrated corridors that I think perhaps could help cool down the city in the summer, because I've been here I think once in the summer and it was quite hot. So perhaps that could be something that the city could emphasize. But I'm also happy to know that the city is taking a leading role, because I understand one of the offices of UN Habitat is also here. So at least when it comes to actions originated from Japan, the city is already taking a leading role, and I'm also aware of the energy-related initiatives. So I hope to see more actions from the city.
Do you have another questions?
Thank you for very nice talk about the introductory talk about sort of adaptation and mitigation. And I'm a sort of researcher in sort of computational science. So I just sort of thinking about how to optimize of the strategy or scenario. Maybe sort of probably used in machine learning technique or AI. But if possible, sort of could you briefly sort of explain sort of what kind of sort of technique?
Yeah, so for that, I think it's important to, of course, use new technologies, but it's not always possible to do is using machine learning. But generally, what is important is to take into account the different measures that could affect emissions. For instance, if it is building height, it depends on the type of material that we use. If it is steel, for instance, up to a certain level, we can have optimal mitigation achievements. But beyond that, because of the embedded emission associated with steel production, it could cause a lot of problems. Or if it is a very high-rise building, because we need to rely on elevators, for instance, all the time, then it would not be possible to achieve optimized levels. But generally, I think if we consider all these measures, all these factors together, either using econometric models or using machine learning models, I think it's possible to find out some optimal levels depending on that specific climate. Mm-hmm. Mm-hmm. So an optimized, for instance, level of density for Fukuoka could be different from one that we can recommend, for instance, for Toronto, mm-hmm. Mm-hmm. due to their changing climates.
Okay. Yeah. So still we have a sort of struggling about the sort of making models, yeah. And how to sort of create a sort of realistic data for the input.
Yes, okay. and in fact, there are already some software that we can use for that purpose. For instance, Energy Plus can help us if we have the specific characteristics of that area and region. It's possible to use it to find out the optimal levels.
Okay. Yeah. Thank you.
Thank you.
Thank you so much.
Thank you very much for your nice presentation. So I just want to ask a question about the starting slides of your work. So when you mentioned that future population will mainly grow in a global south, right? So what I hear from all these predictions for future with a changing climate, that once the climate starts to change, there will be a lot of migration from these hot areas, probably the most densely populated areas, to more cooler places. So, and my question is how it happens in IPCC. So, do you consider this mass migration, which could be triggered by climate change and probably accelerated by climate change?
Yeah. Thank you very much. Yeah, that's a very good question. In fact, IPCC is well aware of that. And at least in Working Group 2, there are chapters specifically looking into climate-induced migration. So I mainly work with Working Group 3, so I'm not well aware of what they're doing. But certainly that's something that needs to be considered. Because as you correctly mentioned, while we'll have majority of world population growth, and some even say that close to 100% of future world urban population growth will occur in Africa and South Asia. But they're also the most vulnerable to climate impact. So it is very likely that this will result in climate-induced migration. And that's something that could cause a lot of problems. But yes, that's already been taken account into at least, I think, the SSPs, not RCPs. Yeah. Thank you.
Okay. Any other questions? Yeah, go ahead. The back.
My name is Zovi. I'm from Kyushu University. Thank you for your nice presentation. I'm from Indonesia, so when I see this mapping, one that I realize is that in Indonesia, what we are trying to do is to distribute our wealth. So we want to grow new city, more cities that can be enjoyed by our people. So my question is, in relation to climate action planning for countries that want to do like redistribution of wealth, what sort of migration or adaptation action that is need to be considered? Thank you.
Yeah. Thank you very much. I'm not sure if I can answer that question, but I understand that, for instance, you're now moving the capital, for instance. Yeah, but I think the issue of justice is also very important to be considered when we talk about mitigation and adaptation, because without justice, we cannot get all the stakeholders on board. And for case of Indonesia, although I cannot give you clear answer on what specific mitigation measures should be taken there, but I think it's possible, for instance, given the climate of the region, to, for instance, focus on something that is more linked to reducing the embodied emissions, for instance, because building all those cities requires a lot of new material. But if we focus on, for instance, refurbishment, and also make sure that what measures we take will not result in displacement of people, and will also create jobs, because a lot of these mitigation measures actually can create new jobs, and that way we could also try to enhance the capacity of the people and make sure that this will not result in further injustice in cities, because that's already an issue that we are suffering in many parts of the world.
Okay, one quick question, right?
Okay, thank you very much for your nice presentation. Can I ask about how it works that the policies from the IPCC, how it works around the world? For example, it is about the all around the global issue or specific that area?
Thank you. So if I understand correctly, you want to know that if those policies apply to different countries or not. Yeah, so generally, because when these reports are published, the last step is approval from all countries. So there will be meetings and representatives of all countries would be there, and they should all approve the reports, at least the summaries for policymakers. So yes, these are some things that are applicable to different parts of the world, but they are non-binding. So this doesn't mean that all countries should follow this. These are just policy relevant, but not policy perspective. So, but the report wants to consider the importance of context-specific issues all around the world.
Okay, time has come. Thank you.
Thank you very much.
Let's thank the speaker again. シャリフ先生、ありがとうございました。それでは以上をもちまして、九州大学エネルギー研究教育機構プレナリーセッションを終了いたします。どうもありがとうございました。